Okay guys, these are your notes over optics. So optics and light kind of go hand in hand. This is essentially how light moves through or bounces off of mirrors or moves through lenses. That's what we're going to be looking at here. So to start with, there's something called a plane mirror, and that's plane like the surface, not plane like as in it's a boring one. The angle of incidence is equal to the angle of reflection. We've talked about this before, but basically the angle that it comes in at is the same as the angle that it leaves at. And that's really all you need to know. Angle of incidence is equal to the angle of reflection in a plane mirror. There's not much more to it than that. Three features of images. Okay, so when we're dealing with looking at how images look to us, there are three types. The first one is is magnified or diminished. Magnified means that it's bigger, and diminished means that it's smaller. You also have upright or inverted. Upright is whenever the image comes out looking the way it's supposed to, and inverted means it's flipped upside down. And then finally, you have real or virtual. And this one's going to be really tricky for me to explain to you, but basically virtual means you can't cast it onto a screen. I don't know that I have a way to show you this from home. I'll try to see if I can find a demonstration for you. It's a little bit tricky to show. Basically there's two types of lenses. Two types of things that we're going to be doing. You're either going to have a divergent lens, which is where light diverges or spreads out as it reflects off of or goes through a surface. So if the light spreads out after hitting the lens or after hitting the mirror, it's a divergent one. And then we also have convergent, which is when the light converges or comes together as it reflects off of or goes through a surface. The focus is the point where that light all converges onto. So to start with, we're going to look at concave mirror. So if you look at a concave mirror is a convergent mirror. You can tell that because these lines are coming in and then moving all together to that one point. That point is known as the focal point or the focus. I know that is out of focus, but that's what it is. When you're dealing with a concave mirror, when the image is close up to you, you have a magnified image. We can tell this because if you look at the image that I've copied off of Google here, her hand is much bigger. So since her hand is much bigger, that means it's been magnified. We also know that the image is upright. And the reason that we know that is because the image is in the same direction. Her hand is in the same direction. Her image hand is in the same direction as her real hand. Basically, they're both pointing up in that case. And then 3 is this real or virtual. This is a virtual image. And again, I'll have to see if I can find a good video to explain this to you. Basically, if you tried to project her hand onto a piece of paper, you could never really get that to work. A concave mirror. So for right now, let's just focus on identifying whether it's magnified or upright. For a concave mirror that's far away, it flips it. So if you want to do this, you can take a spoon and look into a spoon. If you look into the part of the spoon that bends in, you have a concave mirror. You can bring it up to your face. As you get close, it should look bigger, and if you pull it away, your image should flip and you should look smaller. So this is like the image of a room, and you can tell that the image is flipped. All right, so if it's flipped, it is inverted. and it is usually diminished. So if you look at your face in a spoon, you grab a spoon, a metal spoon, and look at your face in the spoon, it should be smaller than your real face. And it's inverted because it's flipped upside down. This is a real image, and again, we'll talk more about why later. All right, so concave mirrors are ones that bend in, so the light's coming in from this side, and this side here is the back. All right, a convex mirror, on the other hand, bends out, and so the back is where the slashes are, and the light's coming in from this side now. These are diverging, concave are converging. And so you can take a look at this point. This kind of helps to explain. This one is also all the images that are created here are virtual, and one of the reasons you can tell that is the focus that everything's going through is behind the mirror. So it's kind of like an imaginary focus. So to start with, this is a virtual image. You can see these all the time. In fact, you can just take your spoon and flip it around if you have your spoon. Flip it around, and you should be able to see this one. Almost all the time, they are going to be diminished images unless you're just right up close to it, in which case it'll be the same size. And then they're always upright. This is why you use these typically on mirrors for cars and such. They usually use them also at like Walgreens has them to see if anybody's trying to steal stuff. But basically, it gives you a wide angle view. All right, concave lenses. So concave lenses are divergent as well, meaning that the light is going to diverge out. Concave lenses produce an image that is diminished, upright, and virtual, just like the concave mirror. Usually this is the type of lens that you would use if you were trying to fix your bad vision. So this is if people can't see far away. If you can't see far away, this is typically the type of lens you use, because basically what it does is it takes all of these, like the blurry, this is the blurry light. Oops. Sorry, it takes the light that's blurry and then refocuses it down to points. If you have glasses, you can take them off and look at them. If the glasses are thicker on the edges than in the middle, then you have concave lenses. All right. Finally, we've got a convex lens, and convex lenses are like magnifying glasses, and these are converging lenses. Whenever you're far away, you have three image features. If you're far away, you can look here. I've got an example that's like the top of a house. So this would be the chimney and the roof. But you can tell it's in his hand, so it's really, really small. So basically, the image features for a converging lens, if you're far away, is that it is diminished. All right, it's smaller than it normally is. It's inverted because that house is flipped upside down. In general, chimneys do not operate pointing upside down. And then finally, it is a real image. And again, have to get to that later. I'll show you what that means in just a second. If you're close up, you're acting like a regular magnifying glass, and so of course it magnifies the object. And then it also keeps it upright. And then it is a virtual image. You would never be able to cast this onto anything. Okay? Again, we're not going to be too worried about the real and virtual part right now, but if you can get the magnified or upright part. This, again, is inverted because it's flipped upside down. This is just a house. It's flipped upside down. And this is a magnifying glass. The image comes up upright. If you have a magnifying glass in your house, you can take it, and if you bring it up, like put it up to your eye, things look bigger, and then as you bring it away, they'll get smaller and smaller, and eventually they'll flip. There'll be a point where it gets blurry, and then they'll flip. Okay, so the final thing here are ray diagrams, and so we only have to do ray diagrams for convex lenses, and there's three types. I really do not know how best to get this information to you other than you just to draw it and figure out what it is based upon the drawing. Maybe just kind of memorize it. But basically there's two lines that you have to worry about in order to draw these. The first line goes from the top of the image through the lens and then bends through the focus on the far side. And the second one the second one comes from the focus on this side, hits the lens, and then bends straight. Now where those two intersect is where your image forms. So this is your object, and then our image is going to form where these two lines cross. So our image forms right here. Okay. Again, I don't really quite know how to make this make sense to you right now. I'll see if I can post a video showing how these work a little bit more in detail. Normally I have like little demonstrations I do, but it's kind of tough to do here. This is what would happen if you are looking at a magnifying glass close up. Basically, your image appears to be magnified. It's going to be bigger. How do I know that my image is bigger? Well, the second one I drew here, this guy right here is my image, and this is my object. In my image, my arrow is bigger than my object. Okay? So it's magnified. It's upright. The way you know it's upright is that the lines cross above the line, above this line right here. It means that it's a upright image. And then it's also a virtual image, and the reason it's virtual is because these lines don't actually cross. You have to dot them back. The lines of light continue on out here. They'll never cross in real life, so it's only a virtual image. All right, if you're inside the focus, if you're inside 2f, so like this is twice the focal length, this is the focal length. If you're inside that, then it looks like this. You have one line still going from the top to the lens, bending through the focus, and there you go. And then the second one is going to go through the focus to the lens, and then it will bend straight. So once you do this, where they cross is where your image forms. And so here's our object, there's our image. We're comparing the two. If you look, I think the image is slightly bigger, so it's going to be magnified. How do I know it's bigger? I'm going to look at literally the size comparison. All right, is this bigger than this? Okay, and again, where these two lines cross, that's where your image forms. All right. Okay, so it's magnified. The lines, if the lines cross above, we get an upright image. These lines cross below, so this is an inverted image. And the lines actually cross, so it's a real image. And then finally, if you're outside 2f, we have the same lines, so one line straight to the top to the lens, bends through the focus. One line from the focus, one line from the top through the focus, hitting, and then bending straight. Whoops, bending straight. This is where our image forms. Our image forms where those lines cross. Those lines actually do cross, so we know this is a real image. Okay, this is my image. If we compare the size of this to the size of this, it's smaller, so this is diminished. And then finally, is it upright or inverted? Well, it's upside down, it's below the line, so it's inverted. Okay. Basically, I need you to know what magnified and upright mean. Okay, those are the two key things. If you can remember those things, you're going to be okay. And if you can just know kind of what these look like, these are known as ray diagrams. If you can just kind of know what they look like, just have a general idea of what they look like, that will be helpful. All right. So I guess that's it, and go deer.